Thanks for joining Hasty Maths videos. You can find more videos at hastymath.com. This particular video, I'm going over October 2020 P3 exam. And this one covers in more detail question 3, which looks at functions, the range, and differentiation. Okay. So question 3, if you want to just scroll through the proof. This is question 3. Uses a little bit of the product rule, a little bit of the chain rule mixed together. And it carries on over here. Okay. Still part of question 3. Number question 3b, we look at the range. And the final answer is there. All right. So if you want some more detail, I'm going to go through it now. Question 3. Give myself some room. Okay, we want number 3a. So there's a sketch of a funny looking curve, and then it says it's called this thing, and x has to be larger than this, and that's because that would make, otherwise the denominator would be 0. So we don't want that. So first thing, just ask for what is f dash of x. Of course, f dash of x is the first derivative, or to derive the function. So we're going to derive this function of f. Let me just grab it. So f of x equals 2x plus 3 over, and I immediately just changed this. Whoopsie. Square root, same thing as the power of a half. So I just changed this because it's, now here I use the quotient rule. We can do it this way. I want to just test it against using the product rule. So let's see what that sort of looks like. But anyway, so if you look at it through the quotient rule states that's u dash v minus v dash u over v squared. And this is where our u's, whoopsie, u is the top and v is the bottom of the original equation. Okay, like that. So we need the dashes. The dashes represent first derivative. So first we do u, then we do v. U is the top, v is the bottom. Whoopsie. Okay, first derivative of 2x plus 3, hopefully you should know is just 2. Then let's take a look at this. This uses the chain rule. Now, I've written this incorrect. Oh, interesting what I did there. So I've done this according to the quotient rule. So this is correct. This is correct. If we use the chain rule, we first, remember we're differentiating, so you first times down and then minus 1. Okay, order matters. So it'd be a half times everything inside that bracket stays the same. Minus 1 gives you minus a half. And then because you're doing the chain rule, you still have to, you still have to times by the first derivative of inside the bracket. So first derivative of 4x minus 1 is equal to 4. Okay, that's where that came from. That's where that 4 came from. Obviously, you want to simplify that a little bit. So we end up with a 4 times a half is just 2. And that's going to be 4x minus 1 stays the same. Wow, nice drawing, Tam. And power minus a half. Okay, so now we have our u and our u dash, and we have our v and our v dash. And the next step is to use this nice u dash v minus v dash u. Remember, order matters when you're doing the product rule because of that negative. And I like to go in this order. So u dash v goes that way, and v dash u goes that way. So u dash v would give us 2 times by the whole of v, which is 4x minus 1 to power of a half. And we want to minus from that v dash u. So v dash u is 2, 4x minus 1 to the power of negative a half times by 2x plus 3. Just get my right hand side of the page here ready. Where is it? Is this whole thing? I wrote way too big here. Okay. So that's all over a denominator of v squared. So v squared, we came from v, is 4x minus 1 to power half, negative a half. Excuse me, a half. First one. And we're squaring that. Okay. So when you square that, it's a half times 2 over 1. It's just going to be 1. So our denominator will be 4x minus 1. So we have our denominator. And then the trick here is to take out the lowest factor of the lowest power factor. So if I look at my powers in the numerator, I have a half and I have a negative half. Okay, so the lowest one is negative a half. So we want to take out a common factor of negative a half. Just check there's not a constant. You can also take out, in our case, there's a 2. But we take out the lowest power. So I would take out 2, 4x minus 1 to negative a half. And check, I have to ask myself, so open up my bracket, what's left over? So for this first term, we want to say, what's left over here? Well, the 2 is gone. So you just have to times 2 by 1, which you normally wouldn't write, but just for clarity. And then we still have 4x minus 1. And you say, well, what times by negative a half will make a half? Okay, so what times by negative a half will make a half? Well, negative 1. So we know that this one is negative 1. And then bring down that negative sign, is there, okay? And then the same thing here, the 2 is just times by a 1. This whole bracket is gone because it's over here. And we're just left with 2x plus 3. So again, just to make sure you take out the highest power of, the lowest power in order to make this work. Close my bracket up. Oh, I think I got like an extra bracket there. So that's the big one. Okay. Again, you don't have to write those ones. It's just for clarity, teaching purposes. So if we're following on the right, we're kind of over here, So, oh, did I do something funny? No, I did not. Let's make sure. We have, bring down the 2, 4x power negative a half. 1 times, this will just be 4x minus 1. The negative 1 makes it into the denominator. And then on this side, we have negative 2x, negative 3. Okay, so it just went into the denominator because it was a, I feel like I've done something wrong because my 2 workings don't match. So let me just go check. Negative, negative, half, half. So, okay, my new one is correct. I just think maybe the old one is incorrect, but let's see if it gets us there in the end. Time will tell. Hopefully, if you're watching this, you already know what I've done wrong. So we end up with, don't forget your denominator is 4x minus 1. And I'll do this in a whole different way. I get, oh, what do we get? So 2 over 4x minus 1 power of a half is in the denominator. And this is times by 2 minus 3, 4x minus 1. So I just put that. Oh, that doesn't work. This is times by, that won't work nicely. I don't want to, 4x minus 1 in the denominator minus 2x minus 3. I wonder where it went wrong. Okay. Let's see now. I'm just gonna, again, I feel like something's gone a little bit wrong in my algebra. Put this over 1. Well, this is over 1 in the denominator. So I'm going to type in times and just see what happens. Times by 1 over 4x minus 1 minus 2x minus 3. I'm keeping this like this so that I can see what I'm doing. 4x minus 1 over 1 in division becomes 1 over 4x minus 1. So that's that. Okay. Keeping a track of it. So, wow. 4x, that's to an invisible one. So now we have a like denominator over here and a like denominator over here. So we just need to get a denominator over here that's the same. So I'm going to do that. If I bring these two together and take an LCD of 4x minus 1, then it will be 2x minus 3, and the one has the 1 stays the same, but the 2x minus 3 has to be times by 4x minus 1. Okay. And this is 5.5. This was 5.1. And this is 5.1. It's my fantastic algebra going on here. Nearly there. So now the problem with this denominator is that this one is a half and the other two are ones, but since it's timesing, you can just times top by top and bottom by bottom. So I wonder if, let's see what happens. 2x minus 3 all over 4x minus 1 to 5.5. And I'm just going to add this because I feel like I'm going to get lost if I don't do it. So what I did is I times the 4x minus 1 over here. And then it's 4x minus 1 of 1. Okay. Now we're nearly there. So this cancels with this. This. Something's wrong. Do I persevere or do I end it? Questions in math. Okay, I'm not going to surrender. I'm going to find the mistake. So all right, let me pause to figure out what I did. Okay, I think I solved it. So when I tip in times this, to get rid of this denominator, I tip in times it becomes the blue wasn't there. So it becomes times 1 over 4x minus 1. And then this was a 4x minus 1 to the power of 1. This was a 4x minus 1 to the power of 1. So if you put those two together, it's 4x minus 1 squared. And then that's canceled out. Okay, because it's 1 plus 1 in the exponents. And then we take 2 minus a half, which gives us 3 over 4. So just timesing the denominators together. Timesing the numerators together, this times 1 is this. Timesing the denominators together, it's this plus this. This we've already dealt with. Okay, so we get there in the end. Just a little bit of simplification. We get this and continue. Great. I think this was the answer they asked for. So this was f dash of x. This was the final answer for that section. Let's get to the next question. So this, just to look at it, this is wrong. This is where I went wrong here in my working. A negative times a positive does not make a negative. Okay, so this, my original working has got an error in it, but everything in my new working is correct. What are we on? We're on question 3. Question 3. B, okay. B asks for us to find the range of f. So range of f. So we've put it in the form that they asked. So let's go get that. Okay, here we go. So our f dash of x was this. It's power of 3 over 2. Okay, 1.5. And they say find the range. So if you were to look at range, range has to do with the y's. So what y's exist? Okay, or more specifically, what x's make the existing y's? Okay, so which x's do we need to make the existing y's? It would be asked sometimes, but in this question, they just ask for the range. So you're going to say, well, what y's exist, which would basically be y is going to be some sort of range of some sort of number, or it'll be between two numbers or this way. Okay. So some sort of range of numbers, oh, excuse me, that y will exist on this function. So also when you write your final answer, y is the same thing as f of x. Okay, so you want to write your final answer as f of x. So let's take a look. Well, first we need to solve for x, because if we solve for x, we'll know which x is, and then we can sub that back into the original formula to get our corresponding y's. So let's take a look. Range of f, well, if you want to just look ahead. Okay. Okay. What will the highest point of, or the lowest point be of a curve? So our curve, actually, this one we had some sort of curve. Is this one had a picture? So we can see we have some sort of curve that has a minimum point. So this is minimum point is, well, probably not there. It's more like here. So our minimum point is somewhere there. And we know that this is the y-axis, this is the x-axis. And at some point above this minimum point is the y's we want. So we want to ask the math which x's will give us those y's, so we can find those y's. And then we sub it back into the original equation. Well, we know that min and max is the same thing as the first derivative equal to 0. We know we can find the first derivative equal to 0. Those x's will give us the y's that we want for this minimum value. And if we can take this minimum value, then the y's that we get will be above that minimum value. So the y's above whatever that y is. Okay. So let's do the math. Math is pretty straightforward. I just want to grab my, so let's take this thing and we equal it to 0. 4x, excuse me, over 4x minus 1 to the power of 3 over 2 has to be equal to 0. Now, if you times both sides by 4x minus 1, 3 over 2, it's just 0 divided by this, 0 divided by this whole thing. Okay, it's going to cancel out. So it's just 4x minus 8 equal to 0. We rearrange slightly and we get x is positive 8 over 4, which x is equal to 2. So 8 divided by 4 is 2. And we can sub this into the original formula. The original formula from the question 3 is just this thing, f of x. Sub into f of x. The way we write that is sub 2 into f of x is written f of 2. Okay. So wherever you see an x, you stick a 2 instead. Wherever you see an x, you stick a 2 instead. Boom. And just remember your restriction. X can't be a quarter, because otherwise you make the denominator 0, and we don't have that in math. It's impossible. So I put this in the calculator. I get 7 over root 7. Of course, this needs to be rationalized. Times it by root 7. Oopsie. Over root 7. And you rationalize the denominator. So it'll be 7 root 7 over 7. Okay. 7 root 7 over root 7 times root 7 is just 7. And those 7s cancel out. So our x is root 7. If our x, and this x is going to, if we sub it back in, this was, wait, did I double? I doubled up. That's the answer. So this is not x, this is y. Our y is root 7. So if our y is root 7, okay. When our x was 2, this is the min point. Okay, this is the min point. So we know that our y has to be larger than this, or including this. Okay. So we say our range is that y is larger than or including root 7. Okay. And just make sure that you write your final answer as f of x. Okay, just for P3. My 7s don't want to work today. F of x larger than and including 7. Okay. I think that's the end of question 3. Got there in the end. Yes.